Today, we're going to debunk one of the biggest myths about programming, one that seriously stops so many people in their tracks before they even start.
So here it is, the million-dollar question. Do you really need to be a math whiz to learn how to program? It's an idea we've all heard 1,000 times, right? But is there any actual truth to it?
The answer, loud and clear, is no. Not at all. You see, programming, as our source presents it, isn't a science of numbers. It's an art. And your main tool, the thing you'll be using every single day, isn't equations. It's words. So, here's the crucial point. A programmer is, in essence, a writer. Think about J.K. Rowling writing Harry Potter. She used words to build an entire world. A programmer does the exact same thing, but they're building an application, a website, or a system. But hang on, there is a key difference. Unlike a book, whose value is subjective, a program is measured by a standard of perfection. It has to work, period. There's an old urban legend that Bill Gates once compared Microsoft's progress with General Motors. GM supposedly replied that if their cars had as many errors as Windows, nobody would buy them. And that brilliantly illustrates the level of precision that's required. And this is where it all starts to make sense. The single most important and fundamental skill for developing a programmer's mind isn't solving complex algorithms, but something that seems way simpler: the art of naming. And here we can see that fundamental difference. In math, the name doesn't really matter. You can use X, I, or N. They're just abstract placeholders. The formula works the same. But in programming, the name is everything. Total costs isn't abstract. It tells us exactly what it is and what it's for. It's packed with intent and meaning. In fact, it was this very idea of naming that revolutionized programming. It was the key innovation that transformed a task meant for machines into something that we humans could actually understand and create intuitively. And this evolution is fascinating. In the beginning, programming was just entering ones and zeros, totally incomprehensible stuff. Then we moved on to naming, basic instructions with short commands like move. Today, we write something much more readable, like lunch cost equals lunch cost plus 23. And the future? It'll probably be as simple as just talking to the machine. Add 23 to the lunch cost. Each step gets us closer to our natural language, and it's all thanks to the power of naming. This idea of naming things leads us to a completely new and powerful way of understanding the most basic concept in all of programming: the variable. Most courses will give you a definition that sounds something like this. It's technical, a little abstract, a space in the computer's memory, a strict type. It's correct, sure, but it's not very intuitive, is it? But now, look at this. Our source redefines a variable in a wonderfully simple way. It's a named container. That's it. It's a container, like a box, and it has a name on the label that tells you what's inside. Instantly, the concept becomes tangible and way easier to understand. And the amazing thing is, this idea applies to everything. When you tell Alexa, set a timer for the pasta, you're using named containers. Timer is the container, and pasta is a specific name. You are, in essence, programming with words. Okay, so we've got the philosophy down. Now, how do we actually apply it? How do we master this art of naming to really start thinking like a programmer? Here are a few practical, fundamental tips. Use names that have a clear purpose, that are descriptive. For example, temporary cost is always going to be better than something cryptic like TC. Use verbs for actions, like is close, which tells us the answer is going to be a simple yes or no. And above all, remember the golden rule. You first write code for other humans to understand, and only then for the machine to execute. So, to wrap up, I'll leave you with this question. Look around you right now, in your home, in your office. If you had to give instructions to a computer so it could interact with your world, what names would you use? How would you describe the chair, the light, the coffee maker? That right there, that's the first step to developing your programmer's mind.